These are the notes for 4.3 part 2. They are on inequalities with absolute value. So now we're going to be combining problems with inequalities and absolute values. We're going to just start with an example here. So we're going to solve the absolute value of x is less than 4, and then we're going to graph it. So we're starting with a simple one here. So what we want to keep in mind here is that an absolute value means distance from 0. So what this is saying, I'm going to translate this into words for us because I think this is the best way to think about it. This is saying that the distance from x to 0, that's this part, the distance from x to 0 is less than 4. The distance from x to 0 is less than 4. So let's think about what x could be. I'm going to draw a representation of that on a graph. So we know that from 0 to x, the distance has to be less than 4. So maybe it's 4 units this direction or less. Maybe it's 4 units in this direction from 0 or less. So we know that either way, the distance from x to 0 must be less than 4, so it must be somewhere in here. You could also use a highlighter to do that graphing right there. We want to open circle on each because it can't be 4 units from 0. The distance has to be less than 4. So x must be somewhere in there. That's what that problem means. So if we were going to write this in interval notation, just as practice, we would just say from -4 up to 4. Let's do another one now. We're going to talk about what if the absolute value, or the distance to 0, was greater than a number. So we're going to solve and graph the absolute value of x is greater than or equal to 4. So keep in mind that this means the distance from x to 0 is greater than or equal to 4. Now, you guys aren't going to have to write this every time. I just think it's easiest to think about it this way rather than try and memorize what your answer should look like. So now what we're saying, if we look at this on a graph, is that if we're looking at what x is, it has to be more than 4 units away from 0, at least 4 units away from 0. So it might be 4 units in the positive direction away from x, or it might be 4 units in the negative direction away from x. But we know that the absolute value of x, which means the distance from 0, is bigger than 4. It has to be more than 4 units away. So it could be 4 units away in this direction or this direction, or it could be anything more than 4 units away. So in either of those directions. You could use a highlighter for that too. And if we were going to write this in interval notation, we would say x can be anything from -infinity up to -4, including -4. Or, so use a u, x could be anything from 4 all the way up to infinity. So we use a or on these problems where the distance from x is greater than any number. All right, so if we are looking for something that you guys want to just remember for how to write your answers, I personally don't really like to do this, but we'll write it anyway, just in case. So for absolute value inequalities, sometimes you'll get something like the absolute value of something. I'm trying to write a big uppercase X there, because it could be anything in there. It could be like X plus 3. Sometimes the distance from X to 0 is less than some number. We'll call that number P. We were just using 4 before. So if we look at that on a graph, it would look like this. X, the distance from X to 0 has to be less than P units, so it has to be somewhere in here. Has to be less than P units away from 0. And then if we're going to write that in interval notation, it would look like this. We go from negative P up to whatever P is. And then to write our actual solution, we would say, you can write it in one of two ways. You can say X is greater than P and X is greater than negative P and less than P. Or you could also write it another way. If you wanted to break that into two, you could say, well, first of all, X has to be greater than negative P, and X also must be less than P. So this is a conjunction. We're putting two things together. It's an intersection. We're putting two requirements on P, or on X. It has to be bigger than negative P and less than P. Okay? So this is like the problem you would get. This is how you would graph it. This is an interval notation. And this is how you actually write your solution. Now we're going to talk about the other type. What if the absolute value is greater than some number? So what if we had the absolute value of X is bigger than some number? That means the distance from X to 0 is bigger than some number. It's farther away from 0. So we know that the distance from X to 0 is greater than P units. So maybe P is 3 or 4. It has to be more than that many units away from 0. So in this case, we're not including those P's because it's just less than or greater than. It's not or equal to. And then it has to be more than that many units away from 0. So we're going in these opposite directions. So this one is not a conjunction. This is a disjunction. So our first one, that ends up being a conjunction. An and statement, which is an intersection. This one ends up being a disjunction, which is an or statement, which is a union. Two different things going on here. So this second one, when the distance is greater than a number, if we're going to write that in interval notation, we'd have to put two intervals. We would have to say that X ranges anywhere from negative infinity up to negative P, or X can be anything from P up to infinity. That's our interval notation. It's a union, so we need two separate things there. And then to write our solution, we would say X is less than negative P, or X is greater than P. All right, let's try a slightly trickier one. So we're going to solve the absolute value of 3x minus 2 is less than 4. And then we're going to graph what x could be. Okay, so on this one we have an absolute value being less than. That means the distance from this quantity, oh, I meant to do that in green. That means the distance from whatever this ends up equaling, 3x minus 2 to 0, is less than 4 units total. So the distance from this amount to 0 is less than 4. That's what that absolute value means. Okay, so what I like to do is I just kind of think of this in my head as like, okay, let's call this C. 3x minus 2 is C. We know that has to be less than 4 units away from 0. So I'm just going to draw a little number line. This is not my solution. I'm just going to think of it like this. Okay, my C, this number right here, 3x minus 2, has to be less than 4 units away from 0. So this is where it has to be, right here. Okay, it has to be bigger than negative 4 and less than 4. It has to be in between there. So I'm going to have to write this out in two equations to solve this. Okay, I know that 3x minus 2 has to be greater than negative 4. Okay, that's kind of saying right here, it has to be bigger than negative 4. And I know that 3x minus 2 also has to be less than 4. That's kind of right here, this direction. Okay, so that's saying that quantity has to be less than 4 units from 0. So it has to be bigger than negative 4, but less than 4 to make sure it's within that little area close to 0. Now we're just going to solve each of those two things. So on each, I'm going to add 2. So I've got 3x is greater than negative 2. And then we divide by 3. So x is greater than negative 2/3. Okay, that value of x will make sure that we stay over here. Okay, not more than 4 away from 0 in the negative direction. Now we need to find what value of x will keep us close to 0 in the positive direction. So let's solve this one. Same way. I'm going to add 2 to each side. So 3x is less than 6. Then I'll divide by 3. So I know that x also must be less than 2. So I know there's two things that must be in play here. All right. I know that x has to be bigger than negative 2/3 and x has to be less than 2. All right. That's my solution here. That's my actual solution. Now it wants me to graph it. I'm not going to be too picky with your graphs here. I'm just going to put a 0, my negative value, that's a negative 2/3, and my positive value 2. I know that x has to be greater than negative 2/3 and less than 2. So it is going to be right in here. I don't know if you guys can hear right now, but while I'm recording, there's a really loud airplane right outside the window. So sorry if you couldn't hear anything. So if you wanted to, you had to graph it. So that's how we would graph that one. That's what x has to be to make sure that the distance from 3x minus 2, what was our original quantity right here, to 0 is less than 4. So there's our graph. And then if we wanted to write this in interval notation, we would say x must be from negative 2/3 up to 2 with parentheses on each. So there's 3 ways of representing that answer. All right, I've got 2 more examples to do. I want you guys to actually try this one on your own. So I want you to try and solve, graph, and write in interval notation your answer. Okay, here's the problem I want you to try. The absolute value of 8x plus 5 is less than 13. So I made this very similar to the last problem because the distance is less than a number, just like in the last one. So I want you guys to try that. We'll go over it tomorrow in class. All right, one more example we're going to do together. So we're going to say that f of x equals the absolute value of 4x plus 2. And my instructions are to find all x for which f of x is greater than or equal to 6. So in my problem, I have this function called f of x. F of x. Okay, here it is also. It's 4x plus 2, the absolute value of 4x plus 2. I want to know when that, f of x, is greater than or equal to 6. So I really just want to know when this is greater than or equal to 6, because that is f of x. So I want to know when the absolute value of 4x plus 2 is greater than or equal to 6. So keep in mind what this is saying. It's saying that I want the distance from this stuff to 0 to be more than 6 units away or equal to 6 units away. It's got to be more or equal to 6 units away from 0. So that stuff I just circled in green, it can be at 6 units away from 0 in either direction, or it can be more than 6 units away. It can be farther away from 0. Okay, so that's where that stuff in green has to be. This is not my graph. This is not a graph of the solution. Okay, this is just a graph of what that stuff I circled in green could be. Now we have to figure out what x has to be to make that work. So I'm going to write two equations, one for this part, one for this part. So we know that for one thing, my stuff in green, the 4x plus 2, it might be less than or equal to negative 6. That's what that's showing. It might be less than or equal to negative 6. Or it might be something else. Okay, I'll do this part in purple. Or it might be greater than, I can't do it in purple. I can. I'll do this with this. It might be greater than or equal to 6. So maybe 4x plus 2 is greater than or equal to positive 6. That's the hardest part, is writing those two equations about these. That's what's tricky. So let's solve each of those separately now. I'm going to subtract 2. So 4x is less than or equal to negative 8. And then I'm going to divide by 4. So x is less than or equal to negative 2. That's one thing my x could be. That would make my quantity less than or equal to negative 6. Now let's solve the other one. I'm going to subtract 2. So 4x is greater than or equal to 4. Then divide by 4. So x is greater than or equal to 1. So remember, this one is a disjunction because it's going in two different directions. So that's an or statement. X can be either one of those things, and it can be in our answer. It's kind of a nice statement. So this is my solution. X is less than or equal to negative 2, or x is anything greater than or equal to 1. Any of those quantities that fit in there will work. So that's my actual solution. Okay, let's graph that. Like I said, I'm not going to be too picky about graphs here as long as I can tell what your answer is. So my one here in red, x is less than or equal to negative 2. So I'm going to have to go in this direction, less than or equal to negative 2. Or x can be anything greater than or equal to 1. So I start at 1, and I go with anything greater than or equal to 1. Let's see if I can highlight in purple here. Ooh, there we go. And then last, if I wanted to write this in interval notation, I would say x ranges from negative infinity up to negative 2, including negative 2, so I do a bracket. Or, so I put a u, x is anything from 1, including 1, up to infinity. And we always do a parentheses with infinity. All right, so those are your notes for today. If you watch these, you'll be able to work on the homework in class. come with any questions you might have.